Welcome to Unit 1 of Math 2. We are officially into the Math 2 topics. So we are starting with our transformations unit. So today we're going to do a brief overview of transformations and then start doing some investigating on translations. Those of you that are virtual at home, I have linked this in our Canvas site. I highly suggest you take the time to watch this short video. It's about 5 minutes. It is fantastic. It's an awesome way for you to start to understand where these pieces of information we're going to talk about in our transformations unit, where they would actually apply in real life. Plus, it's about Disney and Pixar, and who doesn't love that? So, what is a transformation? There's a few things. A transformation is something that can be reflected, rotated, or slid, and that's going to produce a new picture for us. The picture that we start with, our original, is our pre-image. Our result is called the image. So from now on, we're not going to call them original and new. We're going to call them pre-image and image. One thing that's super important, it preserves length. What that means is that our pre-image and our image are what we call congruent figures. Everything about the first picture is the same size and shape as it was in the second. So our pre-image and our image have the same side length, they have the same angle measurements, they are congruent. The only thing that's different is that it's at a new place on our graph or in our room or whatever it may be. So if you think about taking your bookshelf, for example, in your bedroom, if I turn it and put it on a new wall in my bedroom, it's still the same bookshelf. Nothing about the bookshelf has changed except that it's in a different place in your room. So that's a transformation. So some notation that we need to talk about. We're going to be using what's called arrow notation, and we're also going to use a prime to identify our image. So if this triangle ABC is my pre-image, triangle A prime, B prime, C prime is my image, and this notation here shows that triangle ABC is being transformed into triangle A prime, B prime, C prime. And the more that we practice with this, the easier it will get. So, talking about a translation. A translation is a rigid transformation. My pre-image and image will be congruent shapes. They will only be in different locations on our graph. It's like I'm sliding a picture from one spot to another. So all of the points are going to go in the same direction over the same distance. And we're going to investigate what this means. So there will be times moving forward in this presentation that I ask you to pause your video and try to figure it out on your own, and then unpause the video and see if you agree. So here's example number 1. I have to determine how the X and Y values change from the pre-image to the image. Pre-image is labeled A, B, C. Image is labeled A prime, B prime, C prime. Now, since you are at home, you will not be able to participate in this pair deck. I apologize. But this is a good spot to pause your video, see if you can figure out how to change from C to C prime, or A to A prime, or B to B prime. And I'm going to escape out of this. I'm going to zoom in a little bit. Let's see how that works. Too much. Let's do 100. Okay. Oh, I know what I can do. That's good enough. We're just going to look from A to A prime. So if I'm starting at A, I need to change my direction to get to A prime. So I'm moving my picture to the right and down. So I'm going to use a line to show this, if my computer agrees with me. So I'm starting at A and I'm moving right, and I'm going to change the color and I'm going to change the thickness of the line. If you're doing this at home on paper, you can do this with a marker or a colored pencil or whatever you want. I'm just going to do this with my Google slide. All right, so I have moved to the right and down. Now, because I am doing this on a Google slide, I am going to group these two together, and I'm going to zoom back out a little bit. So if these are moving in the same direction, the same distance, I should be able to move this from C to C prime, and it should be exactly the same, which, hallelujah, it is. And I should be able to do that with B and B prime as well. So I'm going to move it back to A and A prime. If I can figure out the movement from A to A prime, it should be exactly the same for every other point on this pre-image to the image. And ultimately, my goal is going to be able to figure out how to make the X and Y values reflect this. So, can I draw? No, I can't. All right, I'm just going to insert a text box and we're going to go from there. So if I am looking at my A coordinate, A's coordinate is -7, +7. And A prime's coordinate is 2, 0. So our goal is to determine what I can do mathematically to get from -7 to 2 and from 7 to 0. And I'm going to use these red lines that I've created to help our brains. So if you think back to how we did distance last year between 2 points and we started to build a triangle, that's kind of what we're doing. So from A to A prime, how far do I have to go right and how far do I have to go down? Well, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right, and 1, 2, 3, 4, 5, 6, 7 down. So if I'm moving from my X and Y values in my pre-image, what am I doing mathematically to my X value to get from -7 to +2? Well, we just counted. I went to the right 9. If I'm moving from -7 to +2 on a number line, that represents adding 9. And if I'm moving from 7 to 0 on a number line, that represents subtracting 7. So if I took -7 and that was my X value, and I did -7 plus 9, I should get +2. if I take 7 as my y value and substitute in for y, I'm going to do 7 minus 7, which gives me 0. So this, I'm going to circle it just so we have it, maybe. Oh, isn't that lovely? Let's make that transparent. This is my transformation rule, or my translation rule for this specific pre-image and image. So let's look at B. B starts at, I'm going to come back in here. B starts at -5, 2. If I use my translation rule that I have circled up above, what I should do to find my new coordinates for B prime is -5 plus 9 and 2 minus 7, which is going to give me a B prime coordinate of 4, -5. So now I'm going to double check and make sure that that rule actually worked. Well, at 4, -5, I find B prime. So this rule translates every single point, even the points in between on line segments AC or BC or AB. It will translate every point in every segment, right 9, down 7. So let's try another one. Can you write the rule? I'm going to put this back into the screen. Can you write the rule that translates A, B, C, D to A prime, B prime, C prime, D prime? Pause your video. Try to write the rule yourself with X, Y, the arrow, and then what you have to do to X and Y. All right, so coming back. I'm going to use D and D prime in this case. I'm going to get a line. Now I'm only doing these lines so that I can help you visualize it. You do not have to do this every single time if you are feeling confident about, ooh, I'm not feeling confident about drawing a line apparently. It's fine, I can move it. If you feel confident doing this without a line, that's totally fine. If you do not feel confident doing without a line yet, that's fine as well. So I'm going to make this a little bit of a thicker line. I'm also going to make this a easier to see line. And then I'm going to do another line showing me what happens with my X values. All right. Well, apparently I can't connect points today. All right, come on. This is highly obnoxious. I apologize. Okay, now we're in business. So I'm going to zoom back out again. So going from D to D prime. Now the up and down represents the Y. The side to side represents the X. So this distance is 1, 2, 3, 4. So if I want to start creating myself a rule, let's see. We've got X, Y, our original coordinate point is going to turn into, now I'm starting at 1 for D, and I'm working backwards to -3. Since I'm going to the left on the number line, that means subtraction. So I have X minus 4. And then I'm going from -4 to +6. So that represents addition. So I have y plus 10. Now I'm going to double check. Let's try A, for example. Coordinate A is at 3, -6. So 3 minus 4 gives me -1. Is A prime at -1 for an x value? Yes, it is. So what I've done is I'm finding A prime by doing 3 minus 4 for x, and then -6 plus 10 for y. So -6 plus 10 gives me +4, and my A prime value is +4. So this is the rule that translates all of my pre-image to all of my image. So now, doing this with just the rule without looking at a graph at all. Again, this is a really great time to hit pause, try it out yourself, unpause, and come back and see how you did. So I'm going to insert another text box here. I'm going to make the font a little bit bigger so we can see. Maybe. All right, so A prime. I have -1 minus 3. So -1 minus 3 is going to give me -4. And then -3 plus 4 for y is going to give me a 1. How about B prime? Well, B prime starts with an x value of 1. Then I have to subtract 3. So that's going to give me -2. And then it starts with a y value of 1. And then I have to add 4. So that should give me a y value of 3. And last but not least, C prime. C prime is starting with an x value of -1. If I subtract 3 from my x value, that gives me -4. And then I'm starting with a y value of 0. Adding 4 gives me a y value of 4. So these would be my image points based on this translation rule. It is going to the left 3 and up 4. All right, so now I've given you another translation rule. This translation is going to the right 2 and down 3. So now I'm asking you to find the image point of the coordinate 6, 4 based on this rule. So if I'm going to find the image of this coordinate, this is living on the pre-image. So let's call this point A. So A prime would be 6 plus 2, giving me 8. 4 minus 3, giving us 1. Over here, we've given you the image. So we've given you B prime, and now asking you to work backwards to find the pre-image coordinate, or where I would have started to get B prime as my image coordinate. So I'm working backwards. I am doing the opposite of what I did at the beginning. So I got to -3 by adding 2. So if I'm doing the opposite of that, I would go -3 minus 2 to figure out where I started. So that would be -5. I can double check that by saying, does -5 plus 2 give me -3? It does. So same idea. What number minus 3 would give me 2? Well, 5 minus 3 gives us 2. So this would be my pre-image that would have been on my original pre-image coordinate here of -5, 5 to give us an image of -3, +2. All right, last but not least, we have a translation. We're going to perform the translation, and then we're going to find the slope between the pre-image and the image. So I'm going to transfer to my document camera. Make sure it's focused. I would suggest maybe having a separate color and a ruler would be beneficial. So I'm going to start by graphing points A, B, and C. So -1, 0, -2, 3, and 0, 2. So here is A, here is B, and here is C. It is very important now that we are in transformations that we label our coordinates with their proper A, B, C, whatever letter it may be. I'm going to grab another color quick. So the translation is +4, sorry about that, it's +4 minus 3. So that means to the right 4 and down 3. So if I was going to do this on a graph, I'm going to take each coordinate and just go to the right 4, down 3, and place my new coordinate there. So 1, 2, 3, 4, 1, 2, 3. You could also perform this translation on these coordinates, and you should get your resulting coordinates. You can graph those and go from there. You don't have to do it by hand. If I was going to use the rule, -2 plus 4 gives me +2, -3 plus 3 gives me 0. So if I was doing this by hand, I would have 1, 2, 3, 4, down 1, 2, 3, which is B prime, which I got here. And I'm going to just start connecting these. Same thing again. 1, 2, 3, 4, 1, 2, 3. Here is C prime. Now, if you wanted to double check to make sure that all of your coordinates are on the right place that they should be, you could also use the comparison between A and C or B and C on your original. Here I went over 1 and up 2, so over 1 up 2 still gets me to C prime, so we're good to go. So what we're asking you to do in this, if I connect A and A prime, what would the slope of line A prime be? Well, I'm going up and over, so I had to go up 3 and over 4. This is a negative slope, So it is negative 3 over 4. If I did that for C to C prime, same thing, 3 over 4. So C to C prime has a slope of negative 3 over 4. So we would assume that B to B prime has the same slope, which in fact it does. So what this is showing us is that the direction that our points are moving creates these parallel line segments because all I am doing is sliding my picture to the right and down, or to the right and up, or left and down, or left and up. However way I'm translating this graph, it's moving in a direction that creates these parallel line segments. And that's one of the important things to remember about a translation. It's this parallel movement where everything should create these parallel line segments.